A server is essentially used to store and interact with data, and a lot of the time, this data is meant to be private and secure. This means that such servers must have mechanisms to allow access only to certain clients and reject access to other clients. This is generically referred to as access control. Access control generally involves two mechanisms: authentication and authorization. These terms are sometimes wrongly used interchangeably, so let's first define these before we proceed. Authentication refers to verifying the identity of the client, and authorization refers to verifying the rights of the client to perform an action. Let's look at a few examples. In this example, client A is a known client to the server and hence has access to the data. Client B, on the other hand, is unknown and hence cannot access the data. This is based on the identity of the client and hence is a process of authentication. In the second example, client A has access to read some data, but the same client does not have access to write some data. So in this case, the same known client can perform some actions and cannot perform other actions. And maybe there's a third client C who is an admin to the server who has access to do both operations. This is the process of authorization, where we check what rights the client has to perform certain actions. In reality, these both are used together. If first, servers check if a client is a known client, and then they check if this client has the rights to perform the action, and then the client is allowed to perform the action. In this video, we're going to focus on authentication, and in particular for HTTP servers. Before we continue, the rest of this video assumes that you have some familiarity with the basics of HTTP. If you don't, I have a full set of videos covering the basics. I highly recommend that you check those out before continuing. HTTP, as you may know, is a request-response framework. Clients send request messages and servers respond with response messages. HTTP messages, whether they are request messages or response messages, consist of three sections, and HTTP authentication is entirely restricted to the headers. Now let's look at a basic flow, which is common for all HTTP authentication schemes. The client sends a request to get some data, for example. The server returns a 401 unauthorized message with a special header called the www authenticate. This header describes what authentication is expected by the server. The client repeats the request, but this time adds a special header called the authorization header, which contains the expected authentication value with some additional parameters. If the authentication value is accepted by the server, the requested action is allowed, and in this case, the data is read back. I should add a disclaimer before we proceed. Even though the name of this header is authorization as defined in the HTTP specification, this process is still authentication, which means that we are verifying the identity of the client. Authorization of the client can still happen in the background, which is checking the access, but that is not what we are talking about here. These headers have specific formats which are common across different authentication schemes. The www authenticate header defines the authentication scheme and the parameters. The scheme is a string value starting with a capital letter, and the parameters are key value pairs. A server can support multiple authentication schemes for different resources. The authorization header, on the other hand, is a response to this request, so it contains the corresponding scheme and the credentials required by that scheme. The flow example, when updated with this information, looks something like this. However, some of the modern authentication schemes employ multiple cycles of this request-response flow and different values in each of the headers. Sometimes they may even use separate servers to authenticate the client. Some other schemes even employ additional headers like authentication info in the authentication process. There are many schemes for HTTP authentication, and some of the common ones are basic authentication, digest authentication, token-based authentication, HOBA or HTTP origin-bound authentication, mutual auth, OAuth schemes, or some custom authentication. Each scheme has its own nuances, and it's difficult to cover all of these at once. For this video, we will only focus on basic and token authentication schemes. Basic authentication is the simplest form of auth in which the client simply sends the username and the password of the client to the server, and if this value matches the value in the server's database, the client is authenticated. The basic flow is as follows. The client requests some data from the server responds with the 401 with the www authenticate header with the scheme as basic and the realm, we will come to that later. The client responds with the credentials for the basic auth, and then the server returns the data. The authorization credentials are generated in a certain format. First, we take the username and the password, add a colon in between those, encode the value to ASCII, encode the result to base64, and then you get the credentials. Let's take an example. So we can use the test user as the username with the test password, put a colon, encode this to ASCII, which returns the string, and then encode this to base64, which returns the base64 encoded credentials as shown here. And this value is put in the authorization header along with the scheme basic to get access to the server with the basic authentication scheme. The basic authentication method, we are sending the actual password of the user on every request, and this is highly insecure. Even if this data is sent over an HTTPS connection, basic auth is not a very secure method and should be usually avoided for production use cases. In the basic authentication scheme, the client sends the username and the password to the server. In token-based authentication, the client sends something called a token to the server. A token is just any string that contains characters which is compatible with HTTP headers. The token is also opaque to the client, which means that the client cannot derive any meaning from this token. The job of the client is to simply directly pass on the string to the server without modifying it. Let's look at an example to understand the concept of a token. You can think of username and passwords as bank cards. Each card is associated with the customer, and technically only that customer can use the card for monetary transactions. A token, on the other hand, is like a currency note. A currency note has no specific meaning to specific users, and every note of a certain amount means the same whether if it's used by the same customer who has the bank account or somebody else. Tokens, similar to currency notes, are non-personally identifiable, which means that if a third party gets somehow access to the token, they cannot figure out who the user is. This is different in the case of basic auth because there, the third party would be able to identify the username because basic auth directly uses the username. Tokens are also very flexible since the server can choose how to assign access to it, and a single user can create multiple tokens without creating multiple users if necessary. The basic flow for auth using token is as follows. The client makes a request to the server responds with a 401 unauthorized and the www authenticate header. Here I've used the scheme token in quotes because the scheme called token is not a specific scheme. There are different types, so I've put it in a common format, and then the client responds with the authorization header and the token, and then the server responds with a 200, and then the data is retrieved. So the word token, as I said, is not a specific type of auth, but a collective term for multiple subtypes. A token can be any string. It could be a specific API key, which is used in the X API key header. It could be JSON web tokens. It could be multiple types of the OAuth tokens defined in the OAuth 2.0 specification, or it could be any type of custom token. Similar to basic auth, when sending tokens to the server, we must make sure that the token is not readable as plain text and instead use an encryption scheme like TLS. Before we go, you may have noticed the term realm pop up in some of the examples. Let's quickly look at what this is. Realms are essentially URL groups. Here are some examples. The login realm in this example applies to everything under the base login path. So the login realm just means login/whatever that comes after that belongs to the login realm. The same with accounts, the same with admins, etc. HTTP auth is not defined on an entire server, but on these realms. One example might be that the login and the admin realms require digest authentication and the accounts and the orgs require token authentication. Any such combination is possible and allowed by the HTTP specification, and the implementers have a choice to pick whatever they want to use. And finally, the auth that is required for each realm is specified in the www authenticate response as a comma-separated string.